This question is the last question on the first O-level maths paper from 1986. So that's what GCSE papers used to be called back then. And this question is interesting because it's not something that's in GCSE maths anymore. And actually it's not something in A-level maths either. It's only a topic you see in A-level further maths. We get told then that T is a linear transformation, and T can be represented by this matrix, minus 3PQR. We get told two things about how T operates. Namely that it maps 1,8 to 13,1, and it also maps minus 3,4 to K4. We want to use these two pieces of information to find P, Q, R and K. First of all then, let's consider what do these maps actually look like. And if you know about matrix multiplication, then this is left multiplication on these points. So let's write that down. What we've got is this matrix T, which is minus 3 PQR, acting on this point 1,8. And let's vectorize this point. So instead of 1,8, we'll write it as a column vector, 1,8. And it maps it to 13,1. Well, that's a first bit of information, and we can also say the exact same thing for our second piece of information. So the same matrix, minus 3PQR, acting on this point, minus 3,4, well, it maps that to K4. Okay, well, often how these matrix questions work next is we need to form some equations based on the rows that we've got. So first of all, looking at the top row, if we multiply these two together, what we're going to get, we're saying this leads to us saying, well, we've got 1 times minus 3 plus 8 times P. So we've got minus 3 plus 8P, and that gives us 13 on the top row. So that equals 13. And on the bottom row here, we've got 1 times Q plus 8 times R, and that equals 1. So we've got Q plus 8R equals 1. Okay, great, we've got two equations. Let's do the same thing with this matrix down here. So looking at the top rows, we've got minus 3 times minus 3, then we have 9, and 4 times P, so we'll have 9 plus 4P equals K. That's what we see on the top row. And the same thing with the bottom row, we're going to have minus 3 times Q plus 4 times R. So minus 3Q plus 4R, and that will equal 4. This is all the information that we could glean out of the question then. Now we have to use some clever solving equation techniques to find P, Q, R and K. Well, what we should do first is we should zoom in on this equation. And the reason why is because this is the only one that has just one unknown. We've got minus 3 plus 8P equals 13. So let's think about what that tells us. Minus 3 plus 8P equals 13. If we add a 3 on each side, we'll get 8P equals 16. And then dividing by 8, we get P equals 2. Great, we've now got one of our unknowns. We've got P. Well, we need to now find Q or R or K. And actually, if we know what P is, we can go to this equation next. Because this only involves P and K, So we can therefore find k. If 9 plus 4p equals k, well, let's put that in there. We've got 9 plus 4 lots of p, well, that's 4 lots of 2, that will equal k. 9 plus, that will be 8 to get k, so k will be 17. So far then we've got p and k. We still need to find q and r, and these are ever so slightly more tricky. We've got two equations to use then, and two unknowns. We have to set them up as simultaneous equations. We've got q plus 8r equals 1. So q plus 8r equals 1, and we've got minus 3q plus 4r equals 4. When we write it like this, we should be thinking about eliminating one of these variables. And I think the nicest one to eliminate here will be q. So let's times this top row by 3. So writing these out again, but with the top row multiplied by 3, we should get 3q plus 24r equals 3, and minus 3q plus 4r equals 4. The bottom row hasn't changed at all, but the top row we multiplied all the coefficients by 3. And next we should be thinking about eliminating q, and we can do that by adding the bottom row to the top row, because 3 add minus 3q will give us 0. So the q's will disappear. We'll have 24r plus 4r. That will give us 28r. And on the right hand side we've got 3 plus 4 to get 7. If 28r is 7, r has to be 7 over 28. Well, that's just 1/4. Great, we've now got one more of our unknowns. And actually the last one from here is really easy to find. We can go back and use one of our original equations. So we've got q plus 8r equals 1. Now we know that r equals 1/4, we can substitute that in there. So q plus 8 lots of 1/4 equals 1. That means q plus 2, because 8 lots of 1/4 is 2, equals 1. So q has to be minus 1 when we take away 1 from both sides. Sorry, 2 from both sides. That's it then. We found all 4 of what we needed. P equals 2, K equals 17, R equals 1/4, and Q equals minus 1.